Here are just a few more simple trinomial examples for those of you guys who may be struggling with this. We established in class that a trinomial breaks into two binomial factors. Okay, this is a pattern that pops up in algebra over and over and over again. So the simple fact has to do with the fact that there's not a number in front of x squared. This makes it a heck of a lot easier to solve because I know that to get a plain x squared, I'm going to need an x and an x. And then the pattern that we discovered is that the two numbers at the back always add together to make that middle term and multiply together to make the back term. So it's just like our warm-ups. I need a number that adds, two numbers that add to make -10, multiply to make 24. If I list my factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6, I will see that -4 and -6 are the two that work. And I can set up a box to do that, to actually prove that this works, that it makes what it needs to. So if you need to do that, set up a little 2x2 box and actually confirm that these two binomials multiply together to make the right answer. Sometimes you will have them that are just mixed up in order. Most of you can handle this pretty easily, but I figured I'd just show you. You can treat this the same as if it was in your normal order. You know it's going to break into two binomial factors. You know you're going to have an x and an x to make x squared. And then the numbers that add to make 16 and multiply to make 64 would be +8 and +8. Okay? Again, if you don't believe me, set up a 2x2 box and actually check it. Those multiply together and simplify to this. If it's a multiple choice question, you also need to know that that's the same as saying x + 8 squared. X + 8 times itself. If I end up with, here's a situation that's worth looking at. 5x squared plus 35x plus 30. It doesn't appear to be a simple trinomial because I have that number in front of x squared. Well, what I want you to start recognizing is that you actually have a greatest common factor here. 5 and 35 and 30. I could do distributive property and say, okay, let's take a 5 out front. Then I would need to distribute that to x squared plus 7x plus 6, right? That'll make 5x squared, 35x, and 30. And now I've broken it down to be the simple trinomial. So now I can say, okay, it's going to break into two binomials. I'm kind of just ignore this 5 for a minute. I'm just factoring this inside part. So to get x squared, I'm going to have x and x. And it's going to add to make +7, multiply to make +6, which means I'm talking about +6 and +1. And then the only other thing is this 5 is going to kind of act like its own little factor. So it just pops right out front. And then if I was to do box method with these two and then distribute the 5, it would work out correctly. One last example that does pop up from time to time. When I have a problem that looks really complicated, where we throw maybe another letter in there, x squared and y squared, it's still a trinomial, okay? I still have 3 terms. It's still a simple trinomial because I don't have a number in front of this x squared. So I'm going to go to 2 binomials. I'm going to start with x and x, just like I did with all the other ones. But in order to get a y squared at the back, I'm still going to have those numbers, but there's going to be a y and a y. And then to add to make 18 and multiply to make 77, we're looking at 7 and 11. So +7, y, +11, y. It's just so that when you multiply those together, you get the 77y squared. And again, if I check it, x plus 7y, x plus 11y, x squared, 11xy, 7xy and 77y squared, and then there's that 18. So it looks really different. It's really not. It's the same process. It's just you need those y's on the back. So hope that helps on the paper.